All right, we're starting off with the idea of assignment problems and bipartite graphs. The second half of this whole topic is about assignment problems. The first half was about finding a path through a network. The second is about assigning, it's usually going to be people, assigning people to the right tasks to do something fast or do something to get the highest score, something like that. So assignment problems are situations that involve assigning or allocating tasks, usually to people that have varied abilities to perform those tasks. In the real world, you would want to optimize the allocation of those tasks to do things like minimize costs. So if you're working at Macca's or something, they would put people on to minimize the costs. What you'll notice is if you're approaching 18 years old, when they have to pay you a little more, they're going to probably prefer to give you less shifts, even though you know what you're doing, because they would rather pay someone less who can barely do what they're supposed to do, because it just works out for them in the end. All right? Other things that you might want to optimize is to minimize the time, or you might want to maximize profits. Assignment problems can sometimes be represented with a type of network called a bipartite graph. So this is where your notes should start, and it's just this little bit. Sorry, the bipartite should be in blue as well. So your little subheading, bipartite graph. What is a bipartite graph? It's a network where the nodes are in two distinct groups. You can see the two groups because the nodes in each group aren't connected to each other in the group. They're only connected to nodes across in the other group. So right now, can you just get this down so I can demonstrate what the hell all that text means with this example of 3 children liking colors. Yep. The exhaust sounds pretty nice. I saw you.
Where?
Oh, turning left onto
Yeah, I see it
Was
as
it panel tinted? You should have been looking at the road instead of staring.
well. I was just double checking.
Yeah, you can just double check. He's an Asian man with a Lex. Yeah, your exhaust doesn't sound too far candy. It's like halfway between.
Yeah.
And it's not just the typical incredible sound either. It's somewhere in between. So this is the second half of this topic. I say your name, but it's recording. The first lesson was quite quick. You need to be aware of what a bipartite graph is. It's a network where the nodes are in two groups, and they can be used to represent anything. Get the example down as well, and I'll draw the graph for you. All right, a bipartite graph is a network where the nodes are in two distinct groups. In this situation, 3 children are asked their color preferences. What are the groupings of things? Do I have a group of people there? Do I have a group of colors? So that's the separation. So if you were to draw a bipartite graph for this, this would be the children, colors. There's 3 children. How many colors do we have?
6.
Yep. So I'll just do it in order of as I see them. Unlike the networks that you did for critical path, you can't have the lines crossing over here. Does Adam like green?
No.
Yep. So there'd be a connection there. Does Adam like, what does Adam like next?
Red.
Bianca likes blue. Bianca likes purple. Bianca likes yellow. Carly likes orange. And she likes red. Are there any connections within the groups? Do we have Adam likes Bianca? Ooh. No? It's just across the groups. We don't have the colours liking each other. That's a bipartite graph. And literally you have 3 questions. So I'll stop the recording now.